So in yesterday's lesson, I talked about the mole concept, introducing you to the idea of Avogadro's number, and we did some calculations with the mole. That is not the topic of this lesson. This lesson is meant to introduce you to the concept of molar mass, which will allow us to easily make calculation changes between mass and the mole. So super, super handy. All right, so let's get started. So you should know at this point in your science career that one atom of carbon, and I've just chosen carbon sort of arbitrarily, will have a mass of 12.01 atomic mass units, and that's what we call its atomic mass. And we can get that really quickly from a periodic table. And this particular periodic table is giving an atomic mass value to 2 decimal places, and the units there, of course, are atomic mass units. Well, let's extend this to incorporate the mole. If I were to look at exactly 6.02 times 10 to the 23 atoms of carbon, right? In other words, that is a mole of carbon. Then the interesting thing here is that amount, that number of atoms, okay, equivalent to 1 mole, has exactly a mass of 12.01 grams. So essentially, 1 mole of carbon has a mass in grams that's equivalent to its atomic mass. Now, that is a super useful relationship for us to know because we can extend that to other elements of the periodic table, and that will allow us to interrelate moles to grams. Okay, so the molar mass, essentially, when we use that term, what we're describing is the mass of 1 mole of a substance in grams. And so it's essentially the same thing as atomic mass or molecular mass, except that the units are different. The units will be in grams per mole. And so that's just really useful for us to know. So important for you to know that molar mass and molecular mass are going to have the same numerical value, but different units. All right, so that is it for that. I think we're going to now start by looking at some examples that will allow us to extend this idea into calculations that we can do. So let's do that now. So what I'm going to try to do is to help you work through and develop a formula to allow us to interchange moles and grams using molar mass. So we're going to start with just making sure that you have a basic understanding of the idea. So if you were to see a question like this, what is the mass of 1 mole of sodium? Now, I know that 1 mole of a substance has a mass in grams that can be obtained from the periodic table. And so I have a little snippet of a periodic table. Since I'm talking about sodium, I can see very clearly from the periodic table that sodium has an atomic mass of 22.99 atomic mass units, which means that 1 mole of sodium is going to have a mass of 22.99 grams. Exactly. Okay, so what that also means is that if I had 2 moles of sodium, I would have 2 times the 22.99 grams. If I had 3 moles of sodium, I would say 3 times 22.99 grams. And so really, if I want to know the relationship between my mass and my number of moles, I can look at this and kind of devise a bit of a formula. So it looks to me like the mass is going to be equal to the number of moles times the molar mass. And so that is a really handy relationship for us to know. So you might just sum that up. I've got that actually in the next slide. So let's take a look at that. Okay, so in general, we can say that the mass is equal to the number of moles times the molar mass of that substance. And we get that directly from the periodic table. So let's try an example and let's try another example to incorporate that. But before we do that, I want us to just rearrange this formula in terms of moles, because often we're given mass and we're asked to find moles. And so here I have my moles, and I want to isolate this particular variable, which means I need to get rid of my molar mass. So I'm going to divide by molar mass on each side of my equation. And now I've got a newly developed equation with moles isolated, which would give me, if I just organize that a little bit better, my number of moles is going to be equal to my mass divided by my molar mass. Okay, so now that we have these two different forms of this equation, this one and this one, they're really the same equation, just rearranged for different unknowns. I can go ahead and I can incorporate that into my problem-solving process. Let's take a look at an example. So, in this question, they're saying, what is the mass of 1.3 moles of potassium? Okay, so in this case, I know that my mass is my unknown, but I am given my number of moles as 1.3 moles. And MOL is the short form for moles, as an FYI. And so the other piece to this puzzle is that I need to know the molar mass. And so the molar mass I get from the periodic table. And since I'm talking about potassium, I look on my periodic table and I can see that the molar mass of potassium is 39.10. And so that's an atomic mass, but if I'm equating that to 1 mole, then my units for mass are in grams here. Okay, so now I'm ready to look at my formula, plug in the values, and get going. So I know that mass is equal to my number of moles times my molar mass. And in this case, I'm looking for the mass of potassium. So I'm going to include some subscripts. And so my number of moles is 1.3 moles. And my molar mass is, I should add here, grams per mole, 39.10 grams per mole. And I can even see right here how these units of moles are going to cancel out really nicely and leave me with grams. So that will be perfect. And so when I work out that calculation, 1.3 times 39.10, that's going to give me a value. And we're just going to do a unit analysis here. So I have 50.83, and that would be units in grams. But looking at significant digits, my 1.3 mole measurement tells me I need to round to 2 significant digits here. So I'm going to leave my answer as 51 grams. Okay, and that's 51 grams of potassium. Hopefully you found that to be okay. Let's take a look at another example. So in example number 3, it says, how many moles of copper are there in 45 grams of copper metal? Okay, so I'm going to encourage you to pause this video, give this question a try, and then resume the video when you are ready. All right, I'm going to take this up. Now, I always like to orient myself by writing out givens in a problem. And that just helps me to know what tool is appropriate to use. And so in this case, I am looking for moles. So moles of copper, that is my unknown. I'm given a mass value for copper, and that's 45 grams. And I can easily look on the periodic table to figure out the molar mass of copper. And so depending on the periodic table, you may be given a different number of significant digits for that value. When I look on my most handy-dandy periodic table, I get a value of 63.55 grams per mole. Okay, but that might vary from periodic table. So given the information I have, to calculate the moles of copper, I'm going to take my mass of copper and I'm going to divide it by the molar mass of copper. And that's going to give me 45 grams divided by 63.55 grams, giving me a value, an unrounded value, or raw value, of 0.7081 ... moles. Now, doing my unit analysis, I can see that 45 grams has 2 significant digits and 63.55 grams has 4 significant digits. So I'm going to round to the one with the fewest, and that will give me 2 decimal places in this answer at 0.71 moles of copper. And I'm done. Hopefully you did okay with that. I think we're ready to start another example, so let's do that. Okay, so now we're going to up this a notch, and we're going to look at a slightly different question. So in this question, it reads, what would be the mass of 4.2 times 10 to the power of 24 atoms of iron? Okay, so what makes this question harder is that I don't know a direct relationship between atoms and grams. So let me start by writing out what I am given, and then we'll develop a strategy. So I'm looking for my mass of iron. That is my unknown. But I am given the number of atoms of iron. And I know that I can find my atoms if I know the number of moles of iron, because I know that 1 mole is equal to 6.02 times 10 to the power of 23 pieces. In this case, the pieces are iron atoms. Okay, and so I can also look up the molar mass of iron, because I know that I'm talking about iron. And when I look it up on my periodic table, I can see a molar mass of 55.85 grams per mole. Yours might be slightly different due to significant digits. Okay, so let's tackle that. So the first thing that I would do is I would go ahead and I would figure out the number of moles of iron. And so if I figure out the number of moles of iron, I can then find out the mass. So I'm going to use Avogadro's number to help me out here. So bear with me. Okay, so my first step is going to be, well, I know that I have 4.2 times 10 to the power of 24 atoms of iron. But I don't want atoms, so I need to get rid of them. So I'm using dimensional analysis here. Okay, and I know, because I know that there are exactly 6.02 times 10 to the power of 23 iron atoms in 1 mole. And so looking at my analysis here, I can get rid of atoms, and I'd be left with moles. And so working out that value, and I like to use the EXP button on my calculator, so 4.2 times 10 to the power of 24 divided by 6.02 times 10 to the power of 23. And so I'm getting as a mole value to 2 significant digits, nope, I'm going to have to change that to 7.0. Let me get my raw value though. I've got 6.9767 moles. Of course, that's way more detailed an answer than I can actually express, because my 4.2 has 2 significant digits. So I'm going to say 7.0 moles. So now that I have that value, I know the number of moles that I have. So that's a value that I could input here in my givens. So the next step I'm going to do is I'm going to convert that mole value into grams by remembering that my mass, in this case of iron, is going to be equal to my number of moles of iron times my molar mass of iron. So that's that 7.0 moles. And I'm not going to round that. The original value that I get on my calculator, I'm going to keep that in. I don't want to round that. I'm going to keep my unrounded value till the very end. And I'm going to multiply that by that 55.85 grams per mole. And the value that I'm getting, and I want to round that again to 2 significant digits, but my raw value is 389.651 blah 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 grams, and again that is a lot more detailed of an answer than I am comfortable with given the measurements I have, so I'm going to round that to 390 grams, and that is it. All right, so hopefully you did okay with that, and if you need help, make sure that you reach out. There's another way to do this using strictly dimensional analysis, which I can definitely show if you're interested in it. So now the problem, though, is that, let's just scroll, I'm going to scroll back here, is that every example we've seen so far has only involved elements. But the reality is that many compounds exist out there where we would want to do these types of calculations, right? So how do we do that? How do we navigate that? Well, we would first need to determine the molar mass of the compound. So, the molar mass of the compound is pretty straightforward if you know the formula of the material that you're working with. So let's take a look at this. So if, for example, I were asked to determine the molar mass of sodium chloride, I see in this formula that I have one sodium atom and one one sodium ion and one chloride ion in this formula. And so I know that I have, 1 times the molar mass of sodium, which is 22.99 grams per mole. And for chlorine, I have one chlorine in that situation with its molar mass being 35.45 grams per mole. And so I simply take the sum of the molar masses of all the atoms in that formula, and together they will give me the overall molar mass of the compound. So in this case, I'm getting 58.44 grams per mole. And so it doesn't really get any more complicated than that, except that in certain formulas, we might have multiple of the same atom. So let's just take a look at a couple of examples of that. So if I were to say for you, for example, what is the molar mass of water? The only difference here is that I have a compound where I don't just have one of each atom, I have different numbers of each atom. So I need to take that into account. So for hydrogen, I, in this case, have 2 hydrogens, each with a molar mass of 1.01 grams per mole, right? And then I also have oxygen, but I only have 1 oxygen atom, and it has, each oxygen will have a molar mass of 16.00 grams per mole. Of course, these values, like I said, might change slightly depending on the periodic table that you have. And so 16 plus 2 times 1.01 should give me 18.02 grams per mole. And there's my molar mass for water. Okay, let's do one less example of this type, and then we'll move on to a more complex question. Okay, so often we will have ionic compounds that involve polyatomic ions, and so it's really important we count properly here. And so I have some calcium ions, I have some phosphorus, I have some oxygen. So in this formula, this 3 is telling me that I have 3 calciums. I have 2 times 1 phosphorus, which will give me 2 phosphorus. And I have 4 times 2 oxygens, or 8 oxygens. But I need to multiply those by each of the molar masses. So calcium has a molar mass of 40.08 grams per mole. Phosphorus, there are 2 of them, and each of them has a molar mass of 30.97 grams per mole. And each oxygen, there are 8 of them, but each of them has a molar mass of 16 grams per mole. So working all of that math out, I get that the molar mass of calcium phosphate is 310.18 grams per mole. And just a reminder, when we're doing our unit analysis, when we're adding values, we are conserving the number of decimal places, or we're keeping it in line with the value of the fewest decimal places. So all of these have 2 decimal places, hence the 0.18. All right, so let's take a look at how we can incorporate the molar mass of compounds into the calculations we've been doing. Okay, so in this case, the question reads, what would be the mass of 0.45 moles of magnesium chloride be? Okay, so first of all, let's start by figuring out what we need, and we are looking for the mass, and we're given the number of moles as 0.45 moles, right? Now, if I'm looking for mass, I'm going to need to have my molar mass, and to do that, I need to know what compound I have. And in this case, my compound is magnesium chloride, And so magnesium with a 2+ charge and chloride with a -1 charge, I'm getting that the compound is MgCl2. So over here, when I'm finding out the molar mass, I'm finding out the molar mass of MgCl2. So I have 1 times the molar mass of magnesium, which is 24.31 grams per mole. I'm going to add that in to the molar mass of 2 chloride ions, which is 35.45 grams per mole each. And that's going to give me a value for in its entirety for the molar mass of magnesium chloride. Okay, and so the value that I'm getting here is 95.21 grams per mole. So the only real add-on here is that the molar mass of a compound needs to be calculated before I can figure out the mass of that compound, right? But I'm going to follow the same steps as I did before, right? My mass, in this case of MgCl2, is going to be equal to my number of moles of that substance times the molar mass of that substance. Okay, so in this case, I've got 0.45 moles times that 95.21 grams per mole. You see the units cancel out beautifully. And I'm getting to 2 significant digits, 43 grams. My raw value is 42.8445, but I need to round that to 2 significant digits in aligning with this mole measurement here. And that's pretty much it. So I have one more example that is sort of like just a little bit elevated that I'm going to try, and you're welcome to try it yourself by pausing the video. And so this question reads, how many oxygen atoms are there in 0.15 grams of aluminum sulfate? So pause the video, give that a try, and then see how you navigate this problem. All right, so I'm going to take this up. So in this case, I'm looking for the number of oxygen atoms, right? And so in order to figure that out, I'm going to start, so, O atoms. I don't know that. But I do know that 1 mole is going to have 6.02 times 10 to the 23 pieces. And that I'm going to need to incorporate. And so another thing that I do know is I know that the mass happens to be 0.15 grams, and that's the mass of aluminum sulfate. Okay, so the first thing that I would do here is I would probably just calculate the molar mass of aluminum sulfate right off the bat. Okay, and so I am getting, if I look at 2 aluminums, 3 sulfurs, and 12 oxygens, my molar mass ends up being 342.15 grams per mole. Okay, and so if I'm looking for oxygen atoms and I'm given a mass value, my first step is going to be to figure out how many moles I have, because I can easily, using Avogadro's number, interrelate moles to molecules and then to atoms. Okay, so step number 1. I'm going to say, well, my number of moles is going to be equal to my mass of 0.15 grams divided by my molar mass of 342.15 grams per mole. And that gives me a value of, and please feel free to double check every calculation. Now I'm going to round this to 2 significant digits, but I'm going to get 4.4 times 10 to the negative 4 moles. But that's moles of aluminum sulfate, right? That's not moles of oxygen atoms. And so my next step is going to be to take this one step further. And so I'm going to actually just get rid of this periodic table to give me a little bit more room. So I'm going to take my step 2, and what I'm going to do next is I'm going to say, well, if I know that's how many moles of aluminum sulfate I have, I can figure out how many particles of aluminum sulfate I have. So I'm going to go ahead and do that next. So I have 4.4 times 10 to the negative 4 moles of aluminum sulfate. And so I know that 1 mole of that substance has exactly 6.02 times 10 to the power of 23 formula units of that substance. And so that will give me, if I stop there, then what I'll have is I'll have the number of particles of aluminum sulfate. That's not actually the question. The question is saying, well, how many oxygen atoms do I have? So I need to remember that for every 1 formula unit of aluminum sulfate, I actually have 12 oxygen atoms, right? Remember that? 4 times 3. And so let's look at my unit analysis. I can see that I am canceling out moles of aluminum sulfate. I'm canceling out formula units here. And I am the only unit that I'm left with are oxygen atoms. So multiplying across, I get, so 4.4 times 10 to the negative 4 times my Avogadro's number, and then times 12 is going to give me a value of, my raw value is 3.167 blah 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 times 10 to the power of 21, but I'm going to round that to 2 significant digits at 3.2 times 10 to the power of 21 oxygen atoms. Okay, so that's just a more involved question there. Not your entry-level question, but if you're able to manage that, that's great, and I hope the video was helpful.